Hey everybody, Francisco with the thedevlife. This is the third part of the API series, and in this video I'm going to share with you the database design process I do whenever I'm creating a new database for one of my projects. Welcome back to the channel. If you're new to the channel, I am a self-taught developer with more than 10 years of experience. In this channel, we make videos with the intent for them to become resources for developers. Some videos are technical, and in some other videos, I share insights that I've gathered throughout my journey as a developer. This is the third part of the API series, so if you haven't watched the first and second part, I will place links down in the description if you want to go take a look. In this video specifically, as I mentioned before, we will dive into the process of designing a database. Let's get to it. The approach that I take to design a database, the first step is for me to define or try to figure out all the objects that will be part of the database. So if you haven't watched the other videos, I believe in the first video, in the intro video, I mentioned that the API that we are going to end up with is going to be an API where you can post cars and the information regarding the car. So for example, if you have a car for sale, you would be able to post it on this application and have other people look at it and make inquiries about it. We might not go all the way to the inquiries part, but at least I want to be able to support the listing of new vehicles using this API. The way I would start looking at this is try to imagine a listing. So let's say that we have a listing for a car, and that listing will have the model of the car, it will have the year, the body of the car, whether it's a truck, pickup, sedan, coupe, whatever it might be, the make of the car. It will probably have a description, maybe a picture or pictures. Okay, so this gives us a pretty good idea of the objects that should be included with the car. This gives us the information that you would see on the vehicle listing. In addition to this, we will need the information of the user who posted it, so you are able to maybe contact them, right? So then attached to this, we'll have the user object, first name, last name, email. This will be used to register the user, and we might have a username or handle. I believe that's all the information we would need for the user. Okay, so looking at this, let's break it up into pieces, right? So what are the different objects or entities that need to be stored in the database? So what I can see so far that stands out right away, it is the user or users. We also have cars, we have makes, we have models, we have body types, and we have pictures. We've identified the different entities that we'll have to create database tables for. A lot of people, and I used to do this as well, when you're at this stage, you try to foresee all the different scenarios that you might run into. And sometimes it's very difficult to do that, and you can spend a lot of time going around in circles and just spending too much time on the database design phase, and you don't even get to the development part because you just get overwhelmed with this. So what I suggest here is be thorough, try to come up with identify the different entities that you have to create tables for, but don't aim to be perfect at this phase, because you can later go back and make changes to the database. So whatever initial design you come up with in the initial or the first version of the database doesn't necessarily mean that you will remain there. So I think it's a matter of finding a balance. In this part of the process, the main idea here is to try to identify the different objects that will be involved to be able to support your application. This example is a simple application. There could be databases that have way many more tables. And like I said, as you develop new features, you might have to add new tables in the database, or maybe add new columns to existing tables to support the feature that you are developing. But this is a pretty good point to start. So now we have identified 6 objects so far that will need tables created in the database. So let's go ahead and do that. We will have a users table, and it will look something like this. It will have a user ID. It will have, like we mentioned before, first name, last name, email, and let's go back. Oh yes, we need a username for that, for this table as well. Okay, so this is one of your tables. Okay, the next table will be cars. Okay, so this will have a car ID. It will have, so this will be, the IDs are the primary keys in the database. And then we're going to have, we need to identify or link somehow the car posting to the user who posted it. So there will be a link there from the user ID to this user ID, which is called a foreign key. Okay, so before we continue with that, let's go ahead and create other tables, and you'll see how this connects later on. So let's go ahead and create a table for makes. So this makes will be, for example, Ford, Chevrolet, Ferrari, whatever, brands of cars that you see out there. So let's go ahead and create an ID for this. So this will be a make ID and make. Okay, so then we have there the make, and so now let's link it. So now here we can identify or set a make for this car. So let me explain this. Let me explain the reason why we break out the make, because we could very well go in here and just put the make here as a string as to be part of the database. Now, there's nothing wrong with that. The reason why I like to break it out, and it's good practice to do it this way, is because there could be different variations on the spelling, or maybe somebody misspells one of the makes. And this way, so one benefit is that this way you can control how the spelling should be. So instead of creating a free text field on your application, you can force the user to select from a preset, a list of presets. So for example, from a drop-down, instead of them typing it in, they can go ahead and just select 4 from a drop-down, and you can dictate how 4 should be spelled, and the same thing for other makes. So that's one benefit. The other benefit is that you don't replicate data. So I know that when the application is small, it's not a huge concern. But if you have 1 million cars and you are storing a string with, for example, 4 characters, that is going to take a lot more storage on the database versus storing an integer for the make. So then that's also another thing that you could do. Now, going back to number 1, going back to the first point that I mentioned, if you have different spellings for a make, when you run a query against the database, you might not know how certain users spelled something or spelled a make. So you might get incorrect report data when you run a report or a query against the database. So that is why I like to break it out into different tables. Okay, so let's continue. So the next thing that we are going to break out will be the model. And here it's the same thing that we were doing before, right? So we're gonna have model ID, and you probably guessed it, this will go to a models table. And again, this will be model ID and model. And this, you could call it model or model name, something that makes sense to you. But what we know that this column in the database will hold the actual string for the model. So now these are connected. This is connected to this. Model is connected to this. Now we're gonna do body types. Let's do the same thing. So again, so now you ask yourself this question, right? Okay, well, we have to include the information regarding the body for the car. Now, do you think that this is a situation where people can just start spelling sedan in different ways, or coupe, or maybe come up with their own? So this is a way for you to somewhat control what the input will be whenever a user creates a new listing for a car, right? So I think it's probably a good idea for us to also create a table for body types. And this is also I want to touch on this. A lot of people prefer to just call the primary key ID. From my experience, I prefer to spell it out, even though it's a little longer. And this is because I like to use Entity Framework on my applications. And I'm used to just seeing body type, and I'm used to seeing body type ID. And you'll see in later videos why I am doing this. But my preference, and this is, you don't have to do it this way. You could use ID, you could use ID for the name of the column for the primary key. And we'll have body type here as well. Okay, so what else do we need in the listing info? We need the year, pictures, and description. Okay, so it seems like we are going to need another table for pictures. So let's create it down here. And here, so here we come to an interesting situation, right? So usually what we have seen is that we have a one-to-many relationships on these tables, but it seems like for pictures it will be switched. So for example, there could be one model that is linked to many car listings or many card records. Same thing for the make, right? So we'll have one here, and we could have that same make, for example, Ford, be linked to many different cars. Now here for pictures, we have to make a decision. So if we are going to include only one picture for car, so we could just include the picture ID here, right? And follow the same pattern that we've been following with the other tables. The difference here, this is similar to the users relationship, right? So you have one user that could have many car listings. If we include the foreign key for the picture ID, then we'll be limited to being able to upload only one picture per car. Now, there's two ways we can do this. If the pictures table will not be used by another entity, then we could very well just include the car ID here, like I had done earlier. So we include car ID, and we can build a relationship that way. So we have car that is related to a car ID. And in this instance, it would be one car to many possible pictures. Now, there is an issue here, and let me explain what the issue is. So let's say later on, you come up with maybe the idea that you want to include an image for the users, or a picture for the users. So then what would we do then in that case? We would add a user ID, and then we would link it to the user ID primary key. So now it starts getting a little complicated, right? Now it's like every time we want to use the pictures table for another entity, we have to add a new column to be able to identify what the picture belongs to, and that's not good practice. If you want to do it that way, to where one table is going to be linked to many tables, we have to create what it's called a linking table. And for the purpose of this tutorial, I am not going to create a relationship like that. I will go ahead and share with you to sort of explain how it would work. The way it would work is you could create a car pictures table. And what you would see in this table would simply be a car ID and a picture ID. So this is pretty much just linking and hence the name, right? So you're gonna have a car ID, and this car ID is going to be linked to a picture ID. Now this will allow you to have many car IDs without the need of having this column in the pictures table. But the way that you would find out that a picture belongs to a certain car, you would have to reference this car pictures table to be able to link them back. So whenever you run in a query and you want to get all the pictures for a car, you would just come to this table. The way you would query it is you would query the car pictures table by providing a car ID and coming up with the list of pictures for that car. But like I said, for the sake of this series, I will go ahead and bypass that. But if you in your future applications you see an entity that could be linked to different objects, then you might have to create a linking table for it. Okay, so let's go back to what we will actually be implementing. So we will be leaving out the car pictures table, and we will identify the car a certain picture belongs to on the pictures table. Okay, so now the next thing would be to add a column called path to the pictures table. Okay, so now we have, if we go back to this list, we have covered the model, we haven't covered the year yet. We have the body, we have the make, we have pictures. So we need year and description. For the year, I'm going to make it simple. So since it's going to be a number, there is less chances for errors. So let's go ahead and create a column, and this will be an integer to hold the year of the car. And the next thing will be a description. So here is where users can go in and add text to describe the car. And I think that settles it. So now we have year and we have description. Okay, so it looks like we ended up with 6 different tables. And there's another thing that I want to bring up, and something that might be very obvious to developers who are more experienced. I am not including a timestamp on the different records for the tables. Usually it's good practice for you to have a column that holds the date when the record was created, and maybe another column where to also hold a timestamp when the record was last modified. And sometimes there are objects that you want to be able to deactivate. So for example, for the makes table, if you don't want to allow users to list any car manufacturers that you don't want to support for whatever reason, right? So you can go in here and include a column to either indicate if the object is active or inactive, and therefore on your application make decisions whether you want to display that on your dropdown or to leave it out. And you can do that with many objects here, right? So for example, if a user is blocked, maybe he didn't follow the guidelines, if you have any. For example, if you want to block a user, you can go ahead and set that flag, that column to deactivated. Or maybe you can call that flag is active and set that to false, which is something I see very often. Same thing with cars. So any objects that you think you can apply the flag or that you might have the need to deactivate, you can go ahead and do that. But like I said, for the sake of this tutorial, I'm going to go ahead and leave those things out, just so we can move a little quicker, not just here on the design piece, but also on the database creation, which we'll be doing shortly. And later on when we are actually developing the API, so there will be less fields for us to worry about, which will help us move a little quicker through the process. But just, keep that in mind, that it's good practice for you to record when a record was created or when a record was last modified. Okay, so now the next step is for us to actually jump into SSMS and start creating the database. Okay, so I have SSMS open on my computer. If you don't have access to SSMS and a SQL Server, we created a video. It's part of this series. There's going to be a link in the description, so you can follow that video so you can get SSMS and a free version of SQL Server installed on your computer. So assuming that you already have SSMS and access to a SQL Server, let's get started. So going back to the design that we created earlier in the video, we have 6 tables that we have to create in this new database. So the first step would be to create a new database. So for that, you'll expand, or actually you don't even have to expand it, but just I'd like to see the database being created when it gets inserted. So let's go ahead and right click on databases and select new database. I'm going to leave everything as the default. I'm not going to change anything, except the only thing I'm going to do is name the database, and I'm going to call it CardDB. So let's click OK, and you'll see that now the database is created. Let's go back to the design for the database. We have to create a total of 6 tables here. Let's go ahead and begin with the smaller tables, or the tables that have the least amount of fields or columns in them. So let's go start with makes, and then we'll move on to models. Let's go ahead and right click on tables, right click, new table. And this is going to be the makes table. So let's go ahead and call this the make ID column. It's going to be an integer. We are not going to allow nulls. This is going to be the primary key. And the second field, let's call that make name. And let's change the data type to varchar, and we will allow 50 characters. There's one more thing. So for the make ID, let's make that the identity column. And we go select identity specification, and we simply double click where it says is identity, and that will set it to yes. And what will happen is that now every time we enter a new record on this table, the primary key will increment by 1. Okay, let's go ahead and save this table. This is the makes table. Okay, so we have makes. Let's go ahead now and create the models table. Same exercise. As you can see, sometimes after you create a table, you might not see it pop up under the tables drop down. You can just right click and refresh, and there it is. So now let's create the models table. Right click, new table. This is going to be the primary key, so model ID. Let's select integer again. No nulls allowed. Primary key. Let's say the identity now again, like we did on the previous table. So double click on this identity. Okay, that's set. Now let's add a new field, model name, and this will hold varchar of 50. Okay, now let's save this. Let's call this models. Okay, 2 down, 4 to go. Again, you see that it didn't automatically refresh, so let's right click and refresh, and you'll see it there now. So there it is, models. Okay, let's do body types next. Okay. Same thing, new table, body type ID, integer, no nulls, primary key, and its identity column as well. Excuse me, yeah. Okay, we're good there. Now the next field will be body type name. Again, it will be a varchar 50. And you can specify this if you think you'll need more for whatever database you might be working on. You can specify the length you need. Okay, let's go ahead and save this as the body types. Body types table. Okay. All right. Let's refresh again. 3 down, 3 to go. Okay, so now we get to pictures. Okay, so this is going to be the primary key, picture ID. It's going to be an integer. Let's not allow nulls. Be the primary key. This is going to be an identity column, so let's have it increment automatically again. The next field will be car ID. This will be an integer, and we won't allow nulls on this. Later on in another video, I'll get more into details on how to create foreign keys and how to build relationships between tables, but just so we can move forward, I'm not sure what the length of this video will be. We might end up with a 15-minute video, which is probably more or less where I want to leave it at. I don't want to make it too long. So let's go ahead and leave that complexity for another video. Okay, so far we have the primary key, the foreign key, the car ID, and what's next? The next is the path for the image. So let's call this path. This is again going to be a varchar, but this is going to hold more characters because we might get a path that is long. So let's go ahead and let's do 300 characters, and we could always come back and adjust this if we need it. So now this table is so far the biggest table by the number of fields that we have. Although I've seen a lot bigger, but this is only 3. Let's go ahead and save it now. And we are going to call it pictures. Okay, 4 down, 2 to go. Let's refresh. Okay, we have the pictures. Okay, next let's go with users, and we'll leave cars for the end. Okay, so new table. Right click, new table. Same drill. User ID, integer, no nulls, primary key, identity column, and we have the first name, and let's do 50 characters. Last name, then let's do the email address. Let's make this a little longer just in case. Let's do 100 characters in this. And then we have, I believe, the nickname or username. Yeah, username. Username. And let's leave it at 50. That should work. And we will not allow nulls for the email, nor will we allow an empty username. So let's uncheck that box. Actually, let's also require the first name. The last name can be optional, but let's require at least a first name. Okay, let's save it, and we are calling this users. Okay, now we're down to the last table. 5 and 1 to go. Okay, this one is maybe the most important one that's going to link everything. As you can see, this table is linked to pretty much all the other ones. And you know what? Looking at this, we forgot something very important. We didn't link the body types table to the cars, so we can specify what type of car it is, right? So we will have to add an additional column there. Okay, so let's make that adjustment real quick. Okay, I'm gonna use a different color. So we are going to call this the body type ID field, and that is linked to the body types table. Okay. That will at least serve as a reminder so we don't forget in the future if we reference this diagram again. Okay. So now our last table got even bigger by one more field. All right, let's get started on it. Right click on tables, new. Let's start with the car ID, integer, no nulls, primary key, identity column. Okay. Next thing is user ID. That's also an integer. We will not allow nulls because we need to know who posted the car every time. Then we are going to specify the make ID. This is also an integer, and we don't allow nulls on this one either. We have to specify a make ID. Then we have to specify the model. And again, we don't allow nulls in this one either. Then we have the year of the car, and this will also be an integer, and again we won't allow nulls because we want to know what type of car it is, right? Okay, let's go ahead and add the body type, even though it's going to be out of order. As you can see, we're gonna insert or enter this column after year, and then description will be the last one. It doesn't really matter when we pull the data will be there, but just I guess this will just make it more uniform so we have all the integers together and the string or the text at the end. Okay, so let's go ahead and add body type, ID, integer, not allow nulls. The next one will be description. And this is going to be a varchar, and let's allow 500 characters on this, so a little more. And let's make sure we have the same fields. We have car, user ID, make ID, model. Car ID, user ID, make ID, model. Then we have the year, body type, and description. Year, body type, and description. Okay, so I think we're good. So let's go ahead and save it. And we are going to call this obviously the cars table. Okay, let's refresh. Okay, so at this point, I think we have all the tables, no data in them. And we can check that simply by making a query. So let's start with the makes. So if we right click on makes and select the top 1000 records, SSMS generates the query automatically, and then it executes the query, and you can see that there are no makes there. So an easy way to use the UI to insert new records, you can do that by right-clicking on makes and click on edit top 200 rows. And as you can see, there's no record. So let's go ahead and enter a few. So Ford, let's do Honda, let's do Toyota, Subaru, Lexus. Okay, so at least we have some data there now. So now let's go back to the query and let's rerun it. And there's two ways you can do this. You can click execute, or you can press the F5 key, and that will rerun your query. So as you can see, it's pretty simple to do this. And oh geez, I realized that we made another mistake. So maybe we should fix it. Usually when we have a car model, we probably know that it's a certain model is made by a car manufacturer, right? So by looking at this, I could already see that we made a mistake. So I don't think it makes sense to have a model standing on its own. I think there has to be a relation between the make and a model. So for example, right, Subaru makes Imprezas, but if we just go ahead and in the models table, we just enter Impreza, we won't know that Impreza is made by Subaru. So this could become helpful when we are entering data. So for example, on the UI, I could picture in the UI when somebody needs to create a new listing for a car, the first thing they will do is specify the make of the car. And that should do an additional step to narrow down and only select or make the models available that are made by that brand or that make. So I think here we made a mistake and we need to include another field in this database. And this is for the models database. Let's go back and do that. So models will have also a relationship or a link to make ID. Okay, so let's make that correction to the database. Okay, so let's go ahead and right click on models and script table as create to a new query window. And that will generate a new script to create the table. So let's go ahead and delete the existing models table. Usually when you have a lot of data in a table like this is not the way you would do it. You don't want to delete the table and then recreate it because you would obviously lose data. So you would have to write a script to alter the database to insert only one column at a time. But since we don't have any data, let's just go ahead and delete the whole table and recreate it. So this is the script to create that table. Instead of us going through the UI and redoing everything, it's a lot easier just to come in here and just edit the code. And here, not necessarily code, but the script. So this will have a make ID field now, and it will be an integer. We don't need to specify a size for the integer. And we are going to say that we don't allow nulls in this field. Okay, let's go ahead and create this table. It completed successfully. So now we can close this now. Let's refresh the tables. Let's expand the models now. We should see the new column there. See, now we have the model ID, the make ID, and the model name. So let's go ahead and insert a new record into the model. So we were talking about Impreza. So let's go ahead and insert a new record for models. And we'll do that by right-clicking, edit top 200, and the make ID will, let's add the Impreza. So the make ID is 4 for Subaru. So we'll enter a 4 here, and the model name will be Impreza. Let's enter Civic for Honda. So Honda's ID is 2, and let's enter the model name as Honda. Okay, I think that pretty much wraps up the video. We successfully created a database based on the design. As you saw, we could have spent more time on the design piece to catch those new columns that we're missing. But if you don't, it's okay, because you could always do it when you're actually creating the database. And as you can see, it's not too painful to go back and drop a table and recreate it, especially at this stage when you don't have any data. Well, I hope this video was helpful to you. So please give us a like. It supports the channel, helps out, with the YouTube algorithm. So please subscribe if you think that this video was useful, because we still have more videos left to be published in this series. So thank you, and catch you in the next one.